Hey guys, today we've got another gut sword from the anime manga Berserk. This is a sword commonly known as the Raider sword, sometimes the Golden Age Arc sword. It's the sword that Guts used prior to having his Dragonslayer. Like an idiot, I've already made the sword and shipped it, so I can't even show it to you, so let's just get on with the build. Alright, so first things first, we're going to work on the pommel. I've got this chunk of 2" by 1 3/4. I'm just going to cut off a little section of it, and then I need to square this up in the mill, and then I need to take about 1/4 inch or 6 millimeters off of both dimensions, and we'll get to actually shaping it. Alright, so we've got our nicely machined little block here. I got it within, a couple thousandths of an inch of what I have specified over here in my drawing. So let's do some drilling for the studs on the surface, and we also need to knock down the corners. This might seem silly, but I really like these little continuous chips you get when you have your drill settings dialed in. You can pretty much just continue these forever until they kind of, fling around everywhere. Depending on the size of the cut and how much pressure you're putting, you can get these kind of wide spirals that are like very stretchy and springy, and all the way down either even lighter. And even these little guys, it's just kind of like a little coil spring, basically. The other thing that's pretty cool is all these chips. Nice blue chips. The steel turns blue because it gets so hot when it gets sheared off the steel, but these are fairly sharp. They're not as fun to play with, but they're pretty to look at. Alright, so I need to bevel each corner at a 45-degree angle consistently, and I also need to continue this groove in a 45-degree angle as well. So, full disclosure, I have no idea if this is an appropriate setup, but I've got this 45-degree V-block clamped down pretty securely. I cannot move it, and I'm just going to take this like so. And then if I had an extra hand, I would clamp it. Alright, so here's the finished product. This is straight up the mill. I haven't touched it yet. It looks pretty good, pretty consistent. Now, one of the things I'm going to try is drilling, countersinking, and then tapping the hole all in one step, basically. Using the mill, I'm going to power tap these holes. I've never done it before. Could end in total disaster, but there's only one way to learn. Alright, we got the holes all marked out. We are precisely spaced apart. All the holes line up with each other. They're all centered on that surface. Now, my drill bits are long enough, I'll be able to go all the way through to the other side, but the taps are not. They can only make it roughly halfway, so I'll have to drill, countersink, tap one side, then flip it, and then countersink and tap the other side. Now, I'm going to be using these taps. These are spiral point taps. They are designed specifically for this purpose, for power tapping. This is a tapered tap for starting the hole. You can see it's very gradual on the teeth there at the beginning. And then over here we have the bottoming tap. This is just to finish it. And you can see it goes almost to the very end. Check that out. Huh. It's tightly packed. Huh. Never seen anything like that before. So I've gotten fairly proficient at drilling and tapping these holes, so I figured I'd make a quick demonstration here. I've never power tapped before, and I feel a little more comfortable now, so here goes nothing. I've got the mill slowed down almost as slow as it can go. I've got a lot of cutting oil on that, and I'm just gonna let it feed itself right into that hole. Just touch it to get started. I'm not touching it. It's actually just threading itself right into the hole automatically. I'm just gonna reverse it. And that's that, just one tapped hole. 10 seconds later. Alright, so we've got the guard and the pommel here shaped out and more or less finished, but we need to put all these studs in here. There's 20 studs on this one and there's 10 on this one. Now, what I'm going to do is I'm going to use these things. These are commonly known as carriage bolts. Instead of this knurl section right here, they usually have a sort of a square head, but this is the same idea. It's just for a different application. You would insert these in a hole, kind of hammer it in from that end, and then you can put a nut on the other side, and the knurling will keep the bolt from spinning in place, basically. All I'm going to do is I'm going to chuck this up in my drill, like so, and I'm going to carefully get these letters and numbers at the top here. I didn't see those in the original picture, but need to sand that off, sand off the zinc coating, and there's a very slight flat spot on the top of that dome that I need to shape out as well, but shouldn't take a ton of work. Once I'm done with that, I'm going to grind out the knurled portion there. I just need to make it smaller than the hole so that it will thread all the way in and lie flush on the surface. Alright, so I'll get you on the tripod here because I need both hands, but I'll just show you what I'm working on. I'm getting the studs finished. You can see I've ground away the top knurled portion. I've got the domes done, and I'm just fixing the threads. So I had to chuck each one up in this 3-jaw drill here, and it just slightly, dinged up the threads a little bit. So I'm going to use a rethreading die and run it through twice, and then I'm going to use a nut and just hand thread it on and just make sure it feels nice and smooth. Since I'm going to screw these in with nothing to support it, there's no hex head or slot or anything, I need this to be as friction free as possible, or I'm never going to get it all the way on. I took some old vice grips and I clarenced the jaws so I can grab this like so without interfering with the threaded portion or even this little empty spot, because when I put the die on there, this is the rethreading die, and just 29 more to go. Alright, so it's onto the handle. Now I have this piece of scrap here. This is actually the test piece from my weld strength comparison video. Basically welded handle versus full tang, and I tested it and so forth. You can check it out if you haven't already. It's pretty boring and lame, but I have just enough. This section here before the bend is just long enough. I can cut it out and use it for the handle. I'm gonna cut it down to size, and then I'm gonna bring it over to the lathe, and I'm gonna turn down a small 3/4 inch section to roughly 3/4 inch diameter, and I'm going to put threads on it, and I'm going to hopefully use it to attach to this pommel. I've never tried this before. I always weld them, but given the shape of the sword and all the pieces, it was an excellent machining project. And given that I have a milling machine now, I can accurately make this hole perfectly straight. The threads are perfectly straight, and same with this and using the lathe. So I'll be able to just screw these together and they'll be lined up perfectly, versus I've been known to spend an hour and a half, even 2 hours just setting up one of these welds. It's honestly a ton of work and quite stressful, because once you fully welded it on there, it's not coming off without a ton of work. So in the amount of time it would take me to even just set up this weld, I drilled and tapped this, and I'll be able to turn this down and thread this side, and that's not even counting the welding and then the grinding back and the smoothing out and everything. So I'm giving this a shot. Let's see how it works. Alright, I got you zoomed out a bit here. I believe I'm done with this. Now what I've got here, this is a tailstock adapter. This end has a taper on it. It goes in that tailstock, and this end holds my die, so I can basically have the threads perfectly centered and on level and so forth. So I'm just going to do this by hand. This is a fairly difficult operation, so that's what this little lever is for here. I'll turn the chuck and I'll hold this basically. Threads feel pretty good. Moment of truth, I have not tried this yet. Very nice, very nice. Okay, so we've got the threads on the handle done. I've test fit it. We're happy with that. Now we're on to the next operation. Now, if you don't know what one of these is, this is a dividing head. This can be used to basically rotate any piece and divide it into equal segments. You could do, say 4 segments, and you could make a square. You could mill a perfectly equal square out of this. Or I think you can do up to something like 200 divisions if you were making gears or something like that. But today we're doing something very simple, which is good because I have no idea how to use this. It came with zero instructions on how to assemble it or use it. But for what we're doing, I think we can manage, basically. All I'm looking to do is put 2 flats on this on opposite sides, just to aid in edge alignment of the sword. This was a special request by the customer. The actual sword in the manga and the anime appears to be totally round. In some cases it appears to be tapered, but in all cases it's round. It definitely doesn't have any flat spots in it. Now, if you're not familiar with handling swords, they all tend to have some sort of directional guidance, I guess is the best way I would put it. It's to aid in blade alignment. It'll have flats, or it'll be rounded off rectangular shape or something like that, something to give you some indication without looking at the blade which way the blade is facing. Now, if your edge alignment is off, it makes it very difficult to make good, clean cuts. Even just a little bit will cause the blade to kind of glance off, and it's just kind of a newbie mistake when it comes to sword handling, I guess would be the best way to put it. I'm not going to go too far into this explanation. There are many other channels that highlight, historical sword construction and usage and so forth. So anyway, this is a fairly simple job. I have no idea how to do all the different graduations, but this ring does have degree markings on it. It's got 360 degrees, so I'm just going to start it at 0, and then I'll just rotate it to 180. It's got this little crank on here so I can rotate the chuck basically. So I'm just going to put it on 0 here, if I can do this with one hand, and then we'll just lock this in place. This little, positive stop basically comes out and allows you to lock the chuck. And then we'll make a cut. I'm going to cut about 1/8 of an inch off, and then I'll do the other side and I'll see how it looks. And I'll do a little bit more if I feel it's necessary, but if I come over here, you can see I can't take too much off or I'm going to start hitting these threads, so no big deal. I don't think I'll need a lot of material removal here. Alright, so the handle's all done. I ended up just taking the 1/8 of an inch off of each side, and it pretty much worked out perfectly. It feels great in the hand. I'd say it's a little bit small. I mean, I'm a big guy, I've got big hands. The flats really help you position it, and the rounded parts fit right into the correct parts of your hand, so it feels really comfortable and it feels just natural, but it'll get bigger once I actually put the leather wrap on it, and I think it'll be just right, especially for a more normal sized person.